Thanks and hello to everybody out there in the virtual space after a dense morning session full of product development talks. We are now gradually moving into the validation space, so please stay with us. In this first talk of session 2, I will be introducing the overall validation strategy for the Irish case studies in relation to the EO products generated within the project. Validation of EO data poses its own challenges, and as we fly through the slides, you will appreciate a number of them. Remember that hundreds of data products have been generated so far, and the validation process is still ongoing up till January 2021. Hopefully, too, this talk will set the basis for the other 2 talks in the session and maybe trigger some discussion for session 3. First, I will briefly explain the overall validation strategy, going over a few concepts that will come up during the presentation. I will review the validation datasets used, which effectively are a subset of the ancillary data, then briefly go over the key steps in the Earth observation product and validation, dive into a single case study of validation of satellite-derived bathymetry, and finally refer to the applications and validation connection. In order to meet the overall goal to quality assess the Earth observation products generated, 2 key areas need to be addressed. The first part deals with the data quality and includes quality file checks to validate alignment with user specifications, intrinsic quality indicators, you will see more in the waterlines talk afterwards, accuracy indices, and error measurements on how close to the reference layers are the outputs. And the challenge here is to identify significant reference layers. While it's quite immediate for the bathymetry models, as we do know the error of the soundings, and for the backshore classification, as we have in images or in situ land cover classifications we can use, is not so straightforward for the waterlines, as the instantaneous water edge is something that is not commonly available in the spatial domain. The shorelines can also be complex, as the reference layer use can have large uncertainties themselves. But moving to the second part, which is centered on applications, and this covers verifying if the specified requirements are adequate for an intended use. So, in other words, whether the data is suitable for a specific application, a key concept, considering obviously scale issues and resolution both at the spatial and temporal domain. But these products, in order to be fully assessed, have to be spatially and temporally linked to the validation data. Initially, 5 pilot study areas were identified in Ireland, 4 in the East Coast and 1 on the West Coast. These were selected by a combination of criteria from satellite image availability to coastal type variability, hotspot areas for coastal erosion or coastal flooding, estuaries, and so on. But more important or relevant for this talk was the availability of validation data, which I will refer soon. So in summary, more than 200 kilometers of coastline will be assessed, easily 500 kilometers covering for certain products, 25 years of satellite images from a number of platforms and sensors, with the emphasis on the last 5 to 6 years of sentinel time. With regards to the data used in the validation, this sketch, borrowed from the Interact Cherish project, where GSI is a partner, is useful to illustrate the different systems used. In fact, Cherish datasets, such as DTMs, have been employed by this project as they allow us, as validation data, as they allow us for localized time series analysis, very precise like the instance in Rosler. So staying with elevation data, key dataset, and we're talking here about DTMs and GPS elevation points, you can see in red on the top right corner the most recent GPS field campaign done by GSI this autumn. Important to note is the temporal frequency. Every elevation data point represents a point in space and time, obviously increasing the error uncertainty as we move away from it. Bathymetry is the logical continuation to the offshore, and it's largely InfoMar that fills the gap. Our winter GSI monitoring lines at the temporal dimension in key sites, and we will see an example in Portrane and Rush. Coastal optical imagery, such as VHR satellite, orthophotos, and drone photogrammetry add other aspects to the validation, such as accuracy indices, maps, recent and historical, going backwards to the 6 inches maps even, so more than 100 years old, can add categories and line attribution to that. Finally, almost everything on the coast is referenced to the water level. So tidal datums, an important concept here, which they are generally taken from water level measurements, direct water level measurements, or for model outputs. And in the next slide, I want to share with you the complexity of that, of the tides in Ireland, with just one example, and it might really surprise you. Here I want to briefly illustrate the complexity of the water levels in Ireland with similarities in other parts of the world. The temporal paradox. At exactly the same time that the tide is low in the southeast coast, Wexford, for instance, bottom right figure you can see, is high in Dublin, just above. So exactly the opposite. And what is more relevant in our context, in the EO context, all contained in one single satellite image seen. So you can appreciate the difficulties to assign water levels to certain images, with water lines and shorelines having to be distributed spatially, the water level information. But there's more. As you can see in the left image, the intertidal range variation is very different in the south coast compared to the northern coast, with an amphidrome, so effectively a zero tide, just offshore outflow, so in the middle. And the difference can be up to 4 meters in height, so huge difference along the east southern coast of Ireland. And this is just one challenge that I wanted to share on water levels. There are many others that are hidden more at local level. So an important message is that with the current tide gauge network in Ireland, is not enough to attribute all these lines. We have to supplement it with model data, which is essential not only to validate, but to attribute all the coastal products. To summarize in one slide the key validation steps for each product that you will see in far more detail in the following 2 talks. In the water lines, we are attempting to assess geoposition errors and accuracy indices, narrowing it down to the pixel level. In the shorelines, we are looking at multiple reference layers and the errors associated with these. While in the backshore classification, we are looking at the errors linked to the categorical classes from reference layers, and the internal quality indicators, like the confusion matrices. Finally, in the bathymetry models, we are validated against reference layers, but also against other model outputs, such as the empirical models. Jumping quickly into the satellite-derived bathymetry, the work carried out on SDB has been exclusively performed on Sentinel-2 image, based largely on the last few years of success in Ireland on this field. The quality and high frequency of Sentinel-2 images make it the most reliable source in Irish waters. Why? Well, in short, because we need many images, many Sentinel images in order to select a good one that can do the job. Also, the 10-meter spatial resolution of Sentinel-2 images is not the biggest limitation factor to consider here, but more the vertical accuracy and the consistency across all the images processed. Here you can see 6 images validated for this area in Portrane, Roche, covering 4 years from 2017 to 2020. This is, by the way, a key area with constant monitoring by agencies in Ireland and county councils. The validation process has been instrumental to flag issues with the SDB processes that are currently being addressed. For instance, significant banding can be seen across these images, but particularly more visible in the August 2019 image. For now, though, we're going to select one output, the June 2019, just above, to illustrate the validation steps that we are taking. The SDB outputs have been cross-compared to the reference bathymetry layer. The differences computed as errors can be seen in the bottom left table by water depth interval. They come up acceptable in the first top meters, below 1 meter mean error, and deeper than 4 meters, the errors become far too large. The results are then cross-validated not only with the reference layer that we've seen before, but also against the outcome of the empirical model to assess the image suitability and processor performance. The empirical model for this area, using the same satellite image, top right, shows a good agreement with the same reference layer between 0 to 6 meters water depths, with average errors below 0.6 meters. So pretty good in these conditions. The empirical models, as opposed to the ones employed in this project, require existing water depth data to be built. We use them here, in this instance, just as a reference tool for the validation. Regarding images, a limiting factor is that only images from April to September are suitable in the Irish context, with good sea surface conditions and water quality. So that turns out to be an average of just 1 image per year at site. So to summarize, in general, these models are very limited to shallow waters. However, bear in mind that these are precisely the areas, the region that is more difficult to survey by ship, making still interesting to fully assess the outputs and how they can be incorporated into products. But moving to the application space and staying in validation, a key question to ask ourselves is whether the validated data is suitable for a specific application, so fit for purpose. For that, we could ask, for instance, for waterlines, can we use the dynamic libraries of the waterline generated with height attributes to build coastal DTMs? For shorelines, can we classify the coast in a simple erosion versus accretion, as in the SAR example from Hoth that you see on the top right corner? And can we even go further and calculate erosion rates? Because these are two different applications. Backshore classification, can we detect seasonal categorical change? And at what scale can we do that? On the bathymetry models, can the outputs be good enough to be used in oceanographic models? Can we monitor change? Again, two different applications. So in other words, it is not enough to say that a particular shoreline is at a distance from a reference layer, for instance, 8.5 meters for accuracy or for error, the high water mark. But we also need to tackle where it can or cannot be used to monitor erosion, for instance. So applications again. So just to finish with the presentation, let me remind you that we are now in the middle of the validation phase in these projects. After an intense year of production, we are just placed on the last piece of this puzzle, but not there yet. More work is scheduled to do in the upcoming weeks in order to complete the validation and automate some of these processes that you will see during the day. Some of the questions related to verifying applications will be addressed as well over the next few weeks, just as it comes the first data quality accuracy assessment. And I thought it would be interesting to share this with you now and to foster maybe the discussion in this forum later on. So with all that, thank you very much for your attention.